Chapter 13, Section 1, Triangle Numbers, Introduction to Recursion. So we're going to begin this chapter with a simple example that demonstrates the power of thinking recursively. We're going to compute the area of a triangle with a width of n, assuming made out of both squares. We're going to assume that each square has an area of 1. This value is sometimes called the nth triangle number. So for instance, if we had the following triangle, which is drawn in your book, you could tell me quite easily that the area of the third triangle number is 6, because I've got 1, 2, 3, 4, 5, 6 little squares. Alright, so, and there's a very simple mathematical equation for that, but we're just going to use this as a demonstration for recursion, so don't think too much about the basics of the equation. So we're going to write a triangle class, right? So public class triangle. And then it's going to figure out, we're going to have a constructor with a parameter, some int width parameter, and we'll save that. Say a width. Alright, so we now know how big it is. And then we're going to have some sort of return value of the get area function. It's actually going to tell us just somewhere something like return area. So that's essentially going to be our triangle class. So if the width is 1, obviously a triangle of width 1, then the area consists of a single square. So this would be a triangle of 1, so the area obviously equals 1. So that's going to be our most simple case. So the dragon's rules: know how to take one step, know how to stop. You're knowing how to stop, that's your base case. Sometimes there can be more than one, but essentially you have to handle directly all your base cases, or all your sort of final smallest values. And then the computer, you're going to force it essentially by using that combined with the next step previous to generate all your other answers. But your base case or your lowest cases, you have to hard code in directly. So public int get area. This is on page 589 in your book. So we know that if width is equal to 1, I'm going to return 1. That is my lowest case. Alright, so that's pretty self-explanatory. Now, if we had a triangle that was slightly bigger, let's say we had one of size 4. Well, we know that a triangle of size 3 is 6. And then the next line, my last line, or the line that has the same number of squares as my width, is just the area of this smaller one plus my width. So I could say that computes the area of any triangle. As long as I know the area of the smaller one, I can just add the width field to the smaller area, and I have the area of the entire triangle. Well, how would we get a smaller triangle? So we would make a smaller triangle and then ask it for its area. So if I have a triangle, I'll just make a smaller one. So again, the dragon's rules, right? Figure out how to make one step, figure out how to take your journey into smaller steps. So we know how to make one very small step, and this is our know how to stop. So if width equals 1, return 1. Base case. This is where I stop. I don't go any smaller than that. And then I need to break down my journey. So I need to make, if I'm not there, if I'm not to this point yet, I need to make a smaller triangle. And the way to make it smaller is to set it up with a constructor width parameter that is 1 smaller than the one I currently have. And then have it compute the area. And the very last statement, in recursion, you will always have a return statement. You will always have two. You're always at least two. You're going to have a base case, and then your I'm not done yet case. Okay. So a recursive computation, the little yellow block, solves a problem by using a solution of the same problem with simpler values. So my base case, know when to stop, right here. If I haven't gotten to here, or as small as I can get, check. If I'm not there yet, next step. Break down my journey into smaller steps. So I have to take a smaller step. I make a smaller triangle that's one size smaller than the one I'm currently working with. Okay. That will then remain open, and then it will check inside of itself if it's smaller, and then it's going to keep opening new ones and new ones and new ones until I get to here. Once I get to there, I return one, and then this one closes, and then the next smaller one adds its width to the returned area. It closes and it works its way out. So this is how an area of triangle width 4 would work. You get area of the initial one makes a smaller triangle of width 3. It calls get area on the triangle with width 3. I'm not down to my base case of width equals 1, so that makes a smaller triangle of width 2. Still not done yet. Call get area on that triangle. So I still haven't made my if width equals 1 yet, so I don't return. That method makes a smaller triangle with a width of 1. It calls get area on the smallest triangle. I have now reached my base case. I know when to stop. I've reached my stopping point. That triangle of width 1 starts the chain of returns. It returns 1, like we told the computer to do so. That method returns 1. Then I go 1 plus my width of the one before it. So this was 2. So now I'm up to a 3. That gets returned to, so this is the triangle of size 1, this is triangle of size 2, this is triangle of size 3, and this is my ultimate triangle of size 4, width 4. So the first one returns 1 to here. I add my width to it, so I get 1 plus 2. So 3 gets returned into here. So then I have 3 plus 3, so I have a 6. That 6 gets returned to the original get area call. And I then have my smaller area, which is currently 6, plus my current width, which is 4. So it ultimately returns 10 to the method that called in the main method. Okay. So 2 key requirements in your book, page 590. Every recursive call must simplify the computation in some way. And there must be special cases to handle the simplest computations directly. You have to hard code your base case into the program. Now this kind of looks funky, and obviously this is not the most simple way of doing an area of a triangle, but remember the call pattern recursive method looks really complicated. This looks really weird, and it's kind of weird to think about it, but the key to designing recursion is to not think about how it's actually going to work. Look at the base case, figure out how to solve that, and then just figure out how to shorten up your problem until you can get there. So the trick to a good recursion problem is solving the base cases, and then just figuring out how to keep calling this, have the method keep calling itself until you get there. Okay. So go ahead if you haven't and write triangle in triangletester.java, page 590, 591.